around 0.5 ppm. That's good. But NOx emission is peak. So you need to decide what air-fuel ratio you have to maintain. Okay. This second picture shows here is what you call efficiency of. This is the efficiency graph of three-way catalytic converter, TWC. Already told you, correct? The the three-way catalytic converter will be put inside the exhaust silencer pipe, so the exhaust goes through this. What is job? Its job is to convert HC, CO, and NOx again, which is coming out of combustion chamber due to improper combustion or misfiring or any other combustion related this one. If it is produced, that will be converted into CO2 plus H2O. That is job of three-way catalytic converter, which is attached to tail pipe. But the three-way catalytic converter also, it has to work efficiently. Means you need to run your engine at stoichiometric air-fuel ratio only. That's why I said stoichiometric air-fuel ratio is called as chemically equilibrium air-fuel ratio. Okay, we will talk about this all this thing when we talk autonomous vehicle. We will be talking about engine also. Of course, the 2023 batch already done the course. They have done IC engine course and also then the introduction autonomous, both courses they would have studied. But 2024 batch, you will be learning more about engine, all those things in coming semester, about when you talk about IC engine pollution control and also autonomous vehicle in the next semester. Okay, right now I'm just giving you the idea. If I want to have less pollution, I have to run my IC engine at SI engine at stoichiometric air-fuel ratio 14.7:1, and then also if I attach my catalytic converter and a tailpipe, then I can reduce my COHC emission considerably. Okay, so you can see that when the catalytic converter efficiency, this is the air-fuel ratio, x-axis air-fuel ratio. For example, 10:1 to say 20:1, for example. At stoichiometric air-fuel ratio only, the efficiency of the catalytic converter. This is 10% efficiency. I can say that this is 10% efficiency. Y-axis 0. This is 50% efficiency. 50 means how much NOx, CO, HC are converted to H2O, CO. If all are converted, I say that 10% efficiency. If nothing is converted, I say 0% efficiency. The three-way air converter conversion efficiency is maximum. All three gases will convert to CO, HC only if you maintain stoichiometry. That's what it says here. You can see that very small band. If I maintain the efficient thermal conversion, all three gases, carbon monoxide, hydrocarbon, and nitric oxides are around 90 to 95%. So if you want the maximum efficiency catalytic converter, you need to run your SI engine not on lean mixture, not on rich mixture, always on the stoichiometric air-fuel ratio. Right? So all SI car, commercially selling cars will be running at stoichiometric air-fuel ratio, because without as per Bharat 6 norms, Bharat 6 norms or Euro 6 norm, all those things, without catalytic converter, you will not be able to reduce CO, HC and NOx to the required level of Bharat norms. We need catalytic converter, but catalytic converter will work efficiently only when you run your engine at stoichiometric air-fuel ratio. So this ECU, what is the job of the ECU, electronic control? To always maintain stoichiometric air-fuel ratio by varying the fuel injected in the inlet port, depending on the throttle condition, water speed, and all these things you have to do. That is the job of the this one ECU. Okay. Then another thing, just I am showing another graph also. This graph talks about this x-axis is the spark angle. In fact, they say before TDC. I told you, because yesterday I told you that when piston is moving up during compression, so the fuel air mixture inside the combustion chamber is compressed. I told you if it is a 10:1 compression ratio, 100 cc engine, this volume is 100 cc. At the end of stroke, it will become 10 cc. The air fuel mixture will be compressed to 10 cc from 100 cc. That then I call my air fuel, that is compression ratio, my engine is called as 10:1. Now before going to compression, entire compression, you have to give a spark, that is called as spark advance. Correct? What already I told you, you get peak pressure inside the combustion chamber at the end of the compression stroke only if around 40 to 50% of the air fuel is burned before the piston reaches TDC during compression stroke. If I give spark early or late, what happens? What shown is this figure. I took this from internet. Correct? It was available internet because easier instead of drawing every time I taught it this one. This is the 0 day, that means TDC position. If piston reaches, I told you, piston is moving from BDC to TDC. Right? This is TDC. Now the piston is moving up. Correct? This piston is moving up. Now, if piston reaches this condition, that is called 0 degree. Already piston reaches to this one. If now you can see that there are 4 graphs: red color, black color, blue color, and gray color. Now let me see that here I gave spark, and this is TDC. Towards this is called as advancing. If I move my spark, give the spark before TDC 1 day. So this is, for example, 5 degree. This is 10 degree. This is 15 degree. This is 20 degree. This is 25 degree. Correct? So I gave spark at 20 degree. See that this is the spark with respect to TDC. 20 degree before I gave a spark, because you can see that the air fuel is compressed. This is the path taken. It is getting compressed. And the temperature increases. Now I gave a spark. Correct? 20 degree before TDC. This is I am talking during the whole thing is we are talking in the compression stroke. This is power stroke. From here, the right side is this, from 0, this is called power stroke. The compression stroke, this is 0 degree if piston reaches TDC. Before that, you have given that. I given 20 degree before. You can see that immediately combustion starts, the pressure rises, fuel is burning. By the time piston reaches TDC, what happened? The peak pressure reached. Correct? The y-axis is pressure inside the inside combustion chamber in bar. Correct? I say that this may be something around, for a small engine, 100cc engine, maybe some 50 bar pressure. They call peak pressure. Okay. Now, if I give at 20 degree, fuel burns for entire duration. Which duration? For the 20 degree duration time. Piston is moving up, compressing. Fuel is burning. Already given the spark. So it is burning. By the time piston reaches TDC, almost 50% fuel, you see the peak pressure is you are achieving. Instead of that, for example, I give spark not at 20 degree, I am giving around 10 degree. Correct? Because same engine. And please know the engine is running around 3000 RPM. Because spark, when you have to give spark, also depends on engine RPM. Now engine is at running constant RPM. I'm only one thing what I am doing is spark timing, theta. When I give spark, 20 degree before TDC I gave, I received peak torque. Correct? I said this is 50 bar, this is around 48 bar, something like that. We can say round of 50 bar. Instead of that, still engine running up to 3000 RPM, I am giving spark at 10 degree, not at 20 degree before TDC. What happened? The pressure was coming, and you can see the second line, the path of pressure burning. Already you can see that at this time, correct? At this point, piston has reached TDC because this is the TDC mark, correct? 0 degree. Now, how much pressure has come? This I say that 5, 10, 15, 20, 25, 30, like that. We said there 50, 35, 40, 45, and 50. If I give a 20 degree, I am getting maximum around 48 bar pressure. I told you higher the pressure developed at the end of the compression stroke. Correct? This is the compression stroke. The whole thing is compression stroke. I am getting 40, 50 bar. So I will get maximum pressure and maximum force, maximum torque. I am good. I am get maximum power. Instead of that, if we given 10 at a 10 degree TDC, instead of giving 20 degree little late after 10 degree, the pressure developed when piston reaches TDC is only 15 bar. But please note that still combustion is happening. Fuel is burning. Correct? Fuel is burning. But it goes to a peak pressure not during the compression stroke. This is already expansion, power stroke, correct? So piston is already coming down. Peak pressure developed is only 40 bar. Instead of 50 bar, I am getting 40 bar, 10 bar less. So the power or torque developed by engine will be less by that much percentage, correct? Around 20% less power. Think further, correct? Think for this graph, really very nice. That's why I want to explain you. Instead of that, I am giving at 5 degree, correct? Compression is happening. I have not given at 20 degree, I have not given to spark. 10 degree, I am giving at 5 degree. So it goes here. The combustion happens. The blue graph. Please see that at this place, it is still around something around 17 or 18 bar only, correct? But after that, combustion is happening inside combustion chamber. Already piston is coming down. Here, piston is going up. Piston is coming from here. This okay, piston is coming down. Volume is increasing. Pressure increase not going to help. Power will be wasted, correct? Yeah, force generated is wasted. But now it goes up and the peak pressure is 30 bar, correct? So here we got 50, here you got 40, here become 30. That means what I say is, if I delay, giving spark delay, if I give my spark closer to TDC, the power development decreases, correct? You can see that suppose I don't give spark at all. The compression happening, I have not given any spark. That is what the grayscale, correct? The pressure without this one, compression pressure is for this engine is something around 10, around 12 to 13 bar. 10 is correct. So this engine compression is 10 bar only. You are not given spark, so combustion did not happen. All the fuel is coming out. What will happen? This will produce HC emission. They call missing. Correct. We say that when spark is missed, missing cycle. If spark has not given by mistake, ECU did not work or something happened, partner, the fuel will come out. All the fuel will come out in the exhaust. So HC emission will be maximum. This is not desirable because we are trying to explain this how this spark. That means torque in the engine is proportional to air-fuel ratio and also spark timing. Correct? You have to give the spark and appropriate time. Again, I told you, if this is for engine 3000 RPM, if engine is going to 4000 RPM, correct? Instead of 3000 RPM, you have to give spark much advance. If you want to get by this one, spark I have to give around 30 degree, not 20 degree, correct? Then only this will go something like this and quickly reach the peak pressure. If engine is running for 5000 RPM, you have to give 35 degree to get the maximum thermal efficiency. Just a minute. Hello. ஆமா அதுங்க இருக்கு. கிறிஸ்து கடை எக்ஸாம் பண்ணுது. ஆமா. ஓகே. Thank you. Correct. If engine speed is increasing, you have to give spark in advance because the time for combustion become lesser because piston is moving faster. Correct. So the torque in SA engine is controlled by air-fuel ratio and spark timing. Correct. So you have to give an appropriate spark angle and also appropriate air-fuel ratio to get maximum torque for given speed of the engine. Okay. So yeah.
I think you already explained this yesterday, but I was just thinking that what is the disadvantage of advancing the spark? Like, if advancing the spark is always better for torque, then
no. You have to give appropriate advance depending on engine speed. No disadvantage. If suppose you wrong timing means, that's what the ECU will do. If spark timing not sufficient, it will adjust the spark timing continuously, see that maximum torque is supplied. That is job. It will control air-fuel ratio and also the spark timing so that maximum torque is coming. That is job of ECU.
Sir, it's basically about extracting the most combustion and the most thrust on the cylinder head, right?
Yes, that's correct. So you want to see that the best combustion happens, all the fuel is burned, so no fuel comes out a HC emission, correct? And so that maximum torque is produced, you will get maximum fuel efficiency.
Yes. So why I was asking because is it the spark timing is directly linked with the cam sensor, right? Or is it
sensor says where is the piston? Cam position sensor says whether the piston is in compression stroke or suction stroke, or exhaust stroke, or power stroke. Right? That's what it says. Cam position.
Uh,
And
yes.
generally, yeah, tell me.
Sorry. So at different RPM, the spark can happen at different timing.
Yeah, you have to do, not happen. You have to do, otherwise you will not get max. That's what I'm explaining you.
Okay.
If engine RPM increases, you have to give the spark much before. You see, at you gave 20 degree at the 3000 RPM, correct? If engine is 4000 RPM means you have to give 30 or 30. You have to find out. You have to map. That's what I'm going to explain. Okay, you have to map in the test bed. Correct. You adjust the spark advance 21 degree, 20 degree, 23, 24. Correct. Set the engine RPM 4000 RPM in dynamometer. Then maintain airfield ratio for 15:1. Then change the spark timing in test bed. You will do in dynamometer in your company. That is what called the spark timing map and airfield ratio map. You have to develop. That will take 6 months to try to develop and put into a commercial vehicle and run it. That's what the job of you. Correct. You will adjust spark timing 21 degree. If engine speed increases, you have to advance. If engine speed reduces, you have to retard. Spark will be advance or retard with respect to engine speed only. It is not constant.
Okay.
Spark is moving towards, correct, towards the TDC, correct. If we change this one, decreasing the spark timing in angle is called as retarding. Correct. So yeah, engine was running, for example, let me say it quickly. If engine was running at 3000 RPM, correct? Engine was running 3000 RPM. The best start time was 20 degree before TDC. Correct. This is 20 degree TDC. Now engine you are accelerating. Engine went to 4000 RPM. This timing is not good. This timing is not sufficient to peak torque because piston is moving faster. Combustion time is fixed. So you have to give this spark maybe 30 degree. How will you find out? Increase the engine speed to 4,000 RPM in dynamometer. Then advance spark 21 degree, 22 degree as your advanced spark, 22, 23, 24. You will see that the peak pressure in your, you would have instrumented your engine in the dynamometer setup with in-cylinder pressure sensor. Correct? This is in-cylinder pressure sensor. In-cylinder pressure sensor you would have put on engine in your test setup. You will be watching. If you watch that, you will see the pressure is increasing, peak pressure increasing as you advance. As the engine speed is increasing, you increase engine speed 4,000 RPM. That means 20 degree is not sufficient. The best for 3. So you will be make it 21 degree. See what is the pressure, peak pressure. It is less. Increase it 22, 24. You will see that peak pressure is increasing like this. It go to again a peak pressure for that RPM at maybe 30 degree. So that is the best timing. If engine running 4,000 RPM, you have to give spark at 30 degree, not 20 degree. Suppose engine was running 4,000. Now you again, because the automobile engine is not a constant speed engine. It is a variable speed engine. You are going to change your vehicles from 0 RPM to 10,000 or maximum speed, depending on single cylinder, multi-cylinder, maybe 5,000, 10,000, as you want. So if again from the 4,000 RPM, speed is coming down. But then if it comes to 3,000, what you have to do? Your ECU should, because ECU is going to measure engine speed. If you see the engine speed is 3,000 RPM, it will set the spark timing as 20 degree. From 30 degree, it will bring it to 20 degree. This is called retarding. Higher spark value reduce as the engine speed is reducing. It is called as retarding. If engine speed is increasing, you move from lower value to higher value. That is called advancing. So this will be done continuously based on engine RPM. And what should be this one? You have to map and store inside your ECU. In the test bed, you have to develop, run the engine different speed, note down and store it as a lookup table. Because spark timing. I will show you in the next slide. Don't worry. Quickly, I will show that. Because today I want to complete this. Okay.
Sir, last question. Sorry. So since we are using engine speed sensor, we have to change the angle. But if we use say crank position sensor, and if you fix a position in which the spark should be done, then we don't have to change this, isn't it? Or
no, there also a change. No, you have cam position directly.
If we have a cam position sensor, then
you don't need, because but anyway you are going to change. Based on cam position, you are going to change. Anyway, you are going to advance or retard. Right?
Yeah.
That is going to happen automatically.
Yes, exactly.
No computation needed. Directly it is going to do. Cam position sensors, yes, because you are saying the cam projection will be there exactly where you want to give this spark. As engine speed changes, automatically it changes, no?
Exactly. Yeah.
Okay, there are two type of controls. One is open loop control, other one is closed loop control, air fuel ratio. In open loop control, you have what you call fuel lookup table that will be stored inside your ECU. They called as lookup table, correct? Fuel table or lookup table stored in the memory of the ECU, correct? And what is input to the ECU? Engine RPM sensor, throttle position sensor. This is for cold stuff, forget it. Based on engine speed and the throttle position, whether throttle is 5%, 10%, 20%, 30%, 50%, already you have created this map, fuel map in the dynamometer. That map is stored in there. So accordingly, the fuel injector will open for so many milliseconds, correct? So engine air fuel ratio is maintained. They call open loop control. Now, but please note that the maps are meant for specific temperature, correct? And altitude. Correct? Atmospheric temperature, altitude varies, then the map is not correct. The map will develop a particular temperature in this one only in your dynamometer. That means if your vehicle you are driving in Chennai, for example, I am driving my vehicle in Chennai. Chennai is the sea level, correct? At sea level, my temperature is 30 degree. Because I did my PhD in this. Because I did not have the facility like what you have test cell, where you can, in your company you have test cell, where you can maintain temperature, humidity, everything in control, but the test cell cost out 10 crore. When I did PhD, I was doing open lab, correct? So my air temperature varying as the day. Morning 30 degree, afternoon in summer it goes to 45, 48 degree. But that means, yeah, as I doing the experiment, temperature varying. So the amount of mass are there when inside the engine is varying. The table what I create is not valid when temperature varies. Similarly, if I put my vehicle, the map inside my vehicle, if I drive my vehicle from Chennai to Ooty or Chimla, high altitude, again, the atmosphere pressure changes, the mass of the air density, correct? Air density, it depends upon temperature and altitude where the vehicle atmospheric. So so the open loop control will not work accurately. It will work, but not accurately maintain what is the air fuel ratio you have prepared. So in that case, you have to put what you call a closed loop air control. You based on your throttle position and engine RPM, the base fuel will be injected. Injector will open for known position which were calibrated in the engine test setup. Then it measures the exhaust oxygen level. From that, it finds out what is current, whether engine is running at stoichiometric or rich or lean. Accordingly, additional fuel will be added. Right? Additional fuel will be added. So base fuel plus the adjustment. Adjustment, I say delta T. This is the base fuel. So, for example, base fuel, I say that 1.5 millisecond injector should open. Plus, the depending upon air fuel ratio using e-geo sensor, the additional air fuel may be 0.1 to 0.5. It will be varying, but based on e-geo sensor, this will be added. That fuel will be that pulse will be given to injector, so the fuel will be varied. They call closed loop control. This how there are two type of controls other than the engine. Correct?
So, any question, sir?
Yeah. Yes, please.
So the base time what you defined, that is like the minimum pulse frequency of the butterfly valve opening for the the inlet valve opening, right?
Yeah, that based on the throttle. See, your driver, you are pressing throttle. No, butterfly valve only you are opening. By pressing throttle, you are opening butterfly valve only. Correct? That is called throttle position. That is based on throttle position. Yeah. Anyway, just a minute. Now I will explain how you are creating fuel map. Correct? This is what you are creating. This one. Please see that my engine is attached to dynamometer, and I run my dynamometer at engine at 2000 RPM. Correct? In test bed. Then I open my throttle by 5% throttle. This is 5%, 10%, 20%, 30%, 40, 50, 100% throttle. This throttle, this is engine speed, 2500, 3000 something. This map, this is my PhD work which I did 20 years before. I told you my PhD work developed indigenous ECU for single motorcycle engine. Remove the carburetor, then design a fuel injection system, that is fluidum, injector, calibration, all these things. Then developing a ECU, hardware, software, calibrating, testing, and finding the mapping. So I generated this map. One among the map I am showing for this is for 125cc Bajaj scooter engine, petrol engine. This is a map I developed in year 2003 or 2004, something like that. Correct? So attached to this figure is not that, is different. So attach the dynamometer. I run my engine at 2500 RPM, 5% throttle. Then the values are nothing but injector opening time in millisecond. Note down. This is injector opening time in milliseconds. Okay. So if now I remember if this injector, what I inject, I use a single hole nozzle. If I open 1 millisecond duration, it will inject something around, if I correct 1 milligrams, I correct 1 milligram or 2 milligram, I don't remember, approximately any one of these. Then, so if I open 1.5, if you take it 1 milligram, if I open injector for 1.5 millisecond, right, 1.500, I will inject 1.5 milligram fuel. When engine was running at 2500 RPM and throttle was open for 5 milliseconds, I got this third. Then I kept my engine speed constant. I increased throttle position 10%. So 10% throttle, more air is going. This 1.5 milligram is not sufficient. I increase fuel to 1.55 millisecond. Injector opening time. Please note that these values are injector opening time in millisecond. So I increase 1.6, 1.65, 1.671. I got maximum torque in the dynamometer. That means when I run the engine at 2500 RPM, 10% throttle, for that particular engine, I need to open my injector. For a particular injector, it is 1.67 millisecond. So it will inject 1.67 milligrams of fuel. I got maximum torque, maybe 2-3 Newton meter. I don't know exact number. We have to see. So now I increase my kept the engine speed same. I open throttle more 20%. So 1.67 millisecond will not provide maximum torque because it seems the throttle was open more air is going. So I have to use all the air. So I started increasing the pulse width to 2.072 millisecond. So that means I am injecting 2.072 milligrams of fuel. Correct? So I think this was I maintain airfield ratio 15:1 if I am correct. Exactly, I don't know whether 15:1 or 15.5:1. That's what I want to maintain. Right?
Sir,
So that for that.
Sir. That is 15:1. Sir.
Yeah, 15:1 I maintain, and so that when I inject open the injector for 2.72 millisecond, my injector was injecting 2.07 milligrams. That gave something around 4 Newton meter torque. So that is for maximum. Like that, every throttle I adjusted. I found what is the best injector opening, so that I get maximum torque for 2500 RPM. 5% to 15% vary. These are the injection pulse I have to do. So I get always maximum torque for that. So then this is one map. Then I change my the engine speed to 3000 RPM. Again, same this one. I created, found out what is the value. Like this. This is called fuel map. This fuel map will be stored in my ECU. What my ECU will do, similarly, being SI engine, I need to find a spark timing also. For same speed and this one throttle position, I found spark advance. Somebody was asking, Amit or Abhijit, somebody was asking, correct? So you can see that when engine was running 2500 RPM, 5% throttle, the particular engine, the spark timing should be 33 degree before TDC. Now I keeping same 10% throttle, you have to increase by spark timing should be at 29 degree TDC. As I go more throttle, the spark timing reduces 28, 26 degree before TDC. Now, if I increase the speed, what happens? You can see that increasing. I told you, if engine speed increasing, you have to go advance the spark 38 degree. At 4000 RPM, 5% it is 44 degree. You can see the 10% throttle, 29, 33, 41. So this map was created in the test cell in IC engine lab. Then what I did, I stored the map inside my ECU. This is my map. Now, in actual later, the engine speed sensor and the TPS sensor, both sensors were given to my ECU. Depending upon engine speed and throttle percentage, ECU will select what should be this one, spark timing, and also the fuel injection duration. This map, correct? Accordingly, you will inject the fuel. That's how it works. They called as open loop control. Correct? This is called as open loop control. You have to develop map and store it in ECU and connect to the actual engine based on TPS sensor, engine speed sensor. ECU will automatically inject, looking at this value, inject, so that you will get the fuel efficiency, less all these things. Okay. Next thing, is the closed loop control. In the closed loop control, in addition to that, you put exhaust oxygen sensor, EGO sensor, and the exhaust pipe, which is also called lambda sensor. That is also given. Lambda sensor, if the airfield ratio of engine is 14.7:1, correct? That is stoichiometric airfield ratio. It will give 400 millivolt signal. This sensor will give 400 millivolt signal. If engine is running lean, that is 15:1, 16:1, it will give 0 volts. Then if 0 millivolts will be given, if 0 millivolts given, you know that if the sensor gives 0 millivolts, you know it is a lean mixer. If it is 400 millivolts, you know it is stoichiometric. If it is 1 volt, correct, this is around 1 volt, 800 to 1000 millivolts, you know it is a rich mixer. And so based on the signal coming from whether 400 millivolts or 0 volts or 800 millivolts, the EC knows whether engine is running at stoichiometric or lean or rich. So accordingly, it varies the fuel pulse width. You can see that this is fuel pulse width, so that the airfield ratio is going rich and lean around 14.7:1. That is stoichiometric. So I told you, if you wanted to use catalytic converter to meet the Bharat 6 standard in SI engine, any car, motorcycle in India, then you need to use TW converter and the exhaust pipe. If you are using TW converter, you have to maintain stoichiometric airfield ratio. For that, you have to use lambda sensor. This is called as closed loop sensor. Okay, I stop here. So we saw 5 examples. Mechatronics, because this is one of the examples for mechatronic system. Robot we saw, then we saw washing machine, automatic camera, then IC engine control. Did we talk about satellite control? No.
Yes.
Attitude control.
Attitude control.
So we saw 5 examples. In exam, you are expected to draw the functional block diagram. Functional block diagram is this. Okay. So this is called functional block diagram. Explain with this graph. With the graph, suitable graphs and functional block diagram, explain open loop or closed loop control of IC engine. An example for mechatronic system. You have to draw this and you make a 3 or 4 mark question. Correct? Your exam is my next one 20.
13th, sir. 13th. Sorry.
It's
not 16th. 1 minute, sir.
No.
I will tell you. Sir, first exam will be on 6th, sir. 6th of October. That is for thermal measurement engineering, sir. Your exam will be on the next 15 days after, sir.
That 20th. If I am correct, this on
20th, sir. 20th.
Yeah, 20th to the midsum exam.
Okay.
Correct. So whatever I cover 2 or 3 days before, generally 1 class before. Up to that, it will be the portion for your exam. Generally.
Okay.
Because Saturday we'll complete on Wednesday. That week Wednesday, what is the portion up to that will be your exam portion.
Sure, sir.
Right.
Okay. Fine. See you tomorrow by 5 o'clock. You have a class. Any doubts you can ask tomorrow. Then we will start on mechatronics. We saw the examples. Tomorrow we will start on what are the components of mechatronic system, modeling mechanic systems. Correct. What are sensors, how they are working. What are the actuators used in mechatronic system, like motors, hydraulic motors, electric motors, servo motors, how they are working. Then we also talk about controls of open loop control, closed loop, PID control, tuning the controllers, all this thing. Then also we'll talk about embedded control design. What is embedded controller? Then we will talk about amplifier, filters, electronic filter used for signal processing. Correct? So we will see, don't worry. Each one will be covered 3 to 4 classes, so you will have in-depth knowledge by the time you complete your course. See you by tomorrow, 5 o'clock.
Thank you so much, sir.
Give your attendance. Yeah, give your attendance.
Thank you, sir.
Thank you.
Thank you, kind of you.
Thank you, sir.